Okay. Hello everyone. Welcome to our first webinar. This was supposed to be an actual meetup event, by the way. Um, Given the new situation that affects us all, we obviously decided to switch to a webinar instead. My name is Amir Zucker. I'm a senior software architect from Code Value, and I lead its web division. In the next hour, Vitaly should do a talk about advanced React concepts around virtual DOM, rendering, and performance. Vitaly is a web architect from Well Done Software, which had just recently merged with Code Value, by the way. Together, we provide professional services in the field of software development and everything around it. We can do so in many ways, be that in remote or distributed, as we like to call it, near shore and on site as well. Uh, do keep in mind that if you want to ask questions, you can actually scroll down where there is an area where you can ask questions, and we will answer all of them throughout the talk. So thanks everyone for joining, and let's have fun. Vitaly, you can take it from here.
Great. Hello, everybody. So, my name is Vitaly Zalman. I work for Well Done Software for like
So people
around 8
are
years
saying
now,
that they can't see your screen,
and
the
I
things that you
worked with
share.
React since it was released.
Just
I work a lot on the performance
everyone,
recently,
can
and
you
also because
maybe
the nature of my
write in the
company
chat?
of Well Done Software, I got to work with many customers. So I saw a lot of architectures, different types of ways of how people build React applications. Also the creator and let's say the sole maintainer of Why Did You Render, which is a library that helps to track renders in React that can be avoided. We're going to talk about it also in the lecture. Okay, so I'm really glad to share my knowledge with you, and let's start. First of all, let's look at this quote from Donald Knuth, which I think is very popular nowadays. It says that we should forget about small efficiencies around 97% of the time. Premature optimization is the root of all evil, yet we should not pass up our opportunities in that critical 3%. And it's really important because I've seen how companies spend tons of time on optimizations of small things, pedantically trying to optimize every small part of their application. And then comes a refactor, and all the time that you've spent on small optimizations is just going to garbage. So what I take from that is that performance is a feature, and it's something that the team should decide when and how much effort they want to put into it. And if you work in a bigger company, you probably have a product department, you probably have a business department, and all these people should come together and decide when and how much effort does the company want to spend on performance, including on specific features. So maybe it is a feature, but it's a very important feature. Pinterest, for example, increased their search engine traffic and signups by 15% by reducing their perceived wait times by 40%. Perceived wait times, which means they didn't even improve the wait times themselves. They just improved how they look. For example, they probably added skeletons or like better loaders or something. Same goes for Cook. They increased their conversion by 7%, decreased their bounce rates by 7%. By improving their website just slightly, they reduced their average load time by less than a second in that case. So imagine how much money for Cook is increasing their conversion by 7%. It's just crazy. And it's all by improving their average load time by less than a second. So make sure your product department aware of this and lets you work on performance. Um, Again, they have much more considerations, but it's all about trade-offs, right? By the way, these figures are from a very important study from Google, and the presentation will be available later, so you can check out the link. Yeah, it's called Why Performance Matters. I want to say a word about performance in general, because before we go into performance of specifically React. So first of all, consider simulating the environment of your real users, because remember that your machines, the machines that developers use, are probably much stronger than that of your average user. It's probably not true for all the different applications that you can build. For example, if you build application for developers, they probably have strong machines, right? But if your average user is, for example, from a developing country, then he probably has a mid-tier phone, a mid-tier mobile device. So always try to find out what devices your users use, try to simulate them, and try to see your application through the eyes of your customer. Another important thing is to measure performance. Now, it's not easy. It's a difficult task, and it's very individualistic, and I really want to make a lecture about this topic sometime. But what you get from measuring performance is, if you assign a score to different versions of your application, you can actually find out if your application improved by certain performance changes. Because many times we think we improve by, I don't know, prefetching things and adding certain types of caches and changing algorithms. But in reality, we make our results worse. So uh, that's a good thing to do. Also, if you track what things are faster and what things are slower, you can decide what performance feature exactly to work on from the different aspects of your application. Uh, Another thing is that when you want to work on performance, first try to understand all the processes in your application in depth. Now, that's really, really important, because if you start working on performance and you just try to voodoo, you won't get anywhere probably. The best thing to do is to understand exactly the processes in your application, and then performance improvements would come naturally to you. So again, React performance are probably not the issues, the issue in most cases if you have performance issues. From what I've seen, people are mostly dealing with network issues like lack of caching, CDNs, wrong protocols, slow servers, lack of pagination, all these things. Um, Over accessing the DOM is also a huge problem in many cases, because React abstracts it from us by manipulating the DOM itself. We only speak with the virtual DOM, but we still have access to the DOM through references. And over accessing the DOM is very, very costly. CSS recalculations for huge layouts is a whole different topic, so I won't touch it here, but it's also a huge one. Over bloating the DOM, making your DOM too big, is also something that's very, very dangerous. And in React, it can be even more dangerous, because if you overblow the DOM, you probably overblow the virtual DOM as well, which is really not a good idea. And we would see why, by the way. Iframes, heavy libraries, and processes that run in parallel to your main application is also a huge deal, because um, if your analytics department adds many, many analytics to your application, and you have all these third parties that open pop-ups and do all these weird things on top of your application, these things might compete with the main process of your application, and they might slow you down significantly, both in network and both in processing power, especially on mobile devices where it's really, really crucial. So keep in mind that all these things might be your issues. But today we're going to talk about React issues, which is slowness in React's life cycles. Yeah, let's get into it. So we're going to use this demo throughout the application. It's basically a button, a parent component, and the child component. You can see how it looks here. And obviously, every time you click on increase counter, the counter here increases. And before we get into the demo, let's talk a little about React terminology. And actually, if that's the only thing you take out of this lecture, I think like I would be really, really happy. Although you probably would get more. So. Anyway, so React component is this, right? It's a recipe on how do we want to handle a certain part of the virtual DOM, including the render, which is how do we want to create React elements. So the React component is a recipe on creating React elements and holding a certain part of the DOM, handling a certain part of the DOM. Now, what's a React element? React element is what we get when we use our beloved JSX syntax, which is basically React create element. Now, I find it very, very useful to always remember that these two are equivalent. Every time you create a React element, every time you call your JSX, use this JSX syntax, you create a React element. These React elements are immutable, and like you can't do anything, you can't change them in any way. And they're the building blocks of the virtual DOM. We're going to look at it more in depth soon, but in general, just remember that what you get from this syntax is immutable. Yeah. Oh, wow.
Enable the chat for a second. Um, is there any attendee here that does see? Okay, I can see people that are able to see the screen.
Yeah, maybe you should try to reconnect or something.
Yeah, those who don't, please try to reconnect. Just bear in mind that this isn't just classic screen sharing where you expect to see his desktop or anything. It's just a share of a slide deck. So if you still don't see it, simply try to reconnect. Hopefully that should do the trick. Okay, so sorry for disturbing. Please continue.
Okay.
Yeah, thanks everyone.
So,
Thanks Vitali for a great
so again, React
presentation.
elements are created
Thanks everyone.
by calling
Yeah, thanks everyone for
React.createElement
joining
on React
us.
components, and we
Um,
get
as it was
immutable
pointed out,
entities, which are
we're going to post
the building
a
blocks of the
link
virtual DOM.
in
Now,
the Code
what's a
Valley
React
website,
component
so feel
instance?
free to
Which is
check it
this
out.
part,
And
which is what
have a good day.
which is the this that we call to do things like this dot
Bye now.
props, right? In all the different life cycles of the React component. That's what we have. That's what the virtual DOMs provides for us when we create different React elements in the same place of the hierarchy, in the hierarchy of the virtual DOM, which means that if I created this in another component that's called, for example, main, and we're going to see many examples later to understand this. That's probably the hardest concept. So if you create this component once with certain props and then with other props, you would receive a React element in the first render and another React element in the second render. And what connects between them is this instance, is the React component instance. And now we're going to see certain examples that would help us understand exactly how it works. And I'm just going to say that that's just an approximation of how the virtual DOM works. And it's enough, and it really helps to grasp React best practices and how to deal with performance issues. But the virtual DOM itself is much more complicated, especially in React Fiber, and in the new version of the React Async is that we're going to be using soon. So that's an approximation, okay? That's our demo component that I showed you before. And first of all, remember that it translates directly to this syntax of create element, which means that the first thing that's created is this, or at least that's the father of all the other things. And we pass it div, because that's a div. We pass it its properties, and then we pass all the children to the create element. Now notice that the child, this component, is actually created by the demo. It's not created by the parent. The parent receives this component, and that's the parent. The parent receives the React element that's created here as a child, and actually it's created by the demo component. That's also a very important distinction between rendered by and parent. The parent of child is obviously the parent component, but it's created by the demo component. After all the different render functions in the parent and in the child, and like all the different render functions are called, we receive this. Now that's a close approximation of how a snapshot of a virtual DOM looks like after all these different renders. And that's what is going to be dumped into the HTML, to the real DOM, from the virtual DOM to the real DOM. That's how it looks. Now, if I click on increase, if I click on this button, I have a re-render of the demo component. And first of all, what happens is that all the different renders run once again, and we receive this new snapshot of the virtual DOM. Then it checks what changed. And in our case, what changed is this function here, and that's the text here. So after the virtual DOM evaluates what changed, it's called reconciliation, which is a very important term in React, reconciliation. After it finds out what exactly changed, it dumps the changes to the real DOM, and it updates only what needs to be updated in the most efficient way possible, probably. And that's essentially React. That's essentially how it works. Now let's look at a more advanced example where we do this. Take a moment and think, based on what I just explained, how the behavior of demo and of child changed if we take the child and extract it out of the demo component. Okay, so what happens here is that the child, the React element of the child component, is created only once here, and it's created. Wait, I'll show it here. Wait, okay, just a moment. So it's created only once when the whole thing is when the script is evaluated. So it might make your evaluation time a little smaller, not significantly slower, but just a little slower. But then your different renders would see this child as just as a building block of the virtual DOM. And this component won't really have a life cycle unless it changes something inside of it, inside its state, its inner state or something. But this component here, sorry, this React element here, it won't participate in the demo's lifecycle. And here how it looks, only the father component re-renders, as you can see. When the demo re-renders, because we clicked on the button, the render function is called. The parent component is recreated because this syntax is equivalent to React.create element. But the child is already a ready building block of the virtual DOM. Also, it's obviously immutable, and you can't do anything. Like you can't go and take the child and like change it in some way. It's immutable, and it renders only once when the script is being evaluated. Now let's look at another example. So that's a behavior that I saw several times. Usually what people are doing this for is when you have, for example, a component like tooltip that you want to show in some cases, and in other cases you don't want to show the tooltip, and you have a component inside of it. So notice how on every click the father disappears here and we only have the child component. Can you spot the anti-pattern here? There is a React anti-pattern here. There is something very, very dangerous going on in this code. So essentially what happens here is that the child component always unmounts. Okay, if you take a moment to think about what it means in practice, it means that if you memoized something inside the child, if you make certain Ajax calls when the child mounts, and just in many different cases, this child loses its life cycle on every click. It's unmounted and mounted. The reason for that is that reconciliation uses a heuristic where it only keeps a life cycle for React elements that are created exactly in the same place in the virtual DOM. So in our case, the parent component was here, and now it's a child component. It doesn't really care or have any way to know that the parent had a child here, and this child is unmounted from here and mounted again here. That's how the virtual DOM works. Now, can you think about a way to achieve this behavior another way? The only way would be this. The only way would be to keep the hierarchy as is, okay? Keep the child always here, but make the parent practically transparent. Make it just pass some property to it on every odd render and hide it. And keep on rendering just the child inside the parent. You can also read about reconciliation in the official React docs, and I strongly advise you look at the official docs all the time. They're just great. They explain everything in a very, very clear way, and I hope I encouraged you to look at them once more. Now, that's a side note. Here I just wanted to show you all the ways in which a component can be rendered. So create element is one of them, and we talked about it before. If an element is created in the same place in the virtual DOM, the React component is re-rendered. Now, unless one of these happen, but about should component update, I won't even talk about it. I think it's you can read about it later. And React Memo, we will talk about it very, very soon. Pure components not necessarily re-render when a new React element is created. If you call set state inside a component, it also re-renders. And force update also re-renders it. With hooks, you have the option to change the state of useState or useReducer, or if a context that is used by useContext changes, your component would also re-render. So all of these are the only ways to re-render a component, essentially. Yeah. Okay, now I just want to check for a moment. There are any questions? Okay, no questions. That's great. By the way, you can ask questions, and periodically I'm just checking if you asked anything. Okay, so let's talk a little about performance in reconciliation. So as I told you before, okay, so the parent here goes through a life cycle upon a render of the demo. And it doesn't matter why the demo got rendered. It in our example, for example, it just because the button was clicked, but it doesn't really matter. If the demo renders, parent have a whole life cycle, but the child is, as I said before, is a static component. So the virtual DOM can just do this. And that's it. It doesn't have to bother with its life cycles and doesn't have to bother with many things inside the child. It just renders it. So that's one way to somehow improve the performance, at least of the render. And as I told you before, the parent component has its life cycle, and it would be a new React element on every render. And the reconciliation would find out that nothing actually changed, and would not dump anything to the real DOM, but the virtual DOM would work a little. What about the onClick function? Well, the onClick function it's not a new listener on the button. The button has its own listener from React, and React would just change the reference of the listener to use this function instead of the previous one. Also notice that in this example, this function is that's always a new function on every single render. So we know this trick, which is a very famous trick in improving performance. So essentially what happens here is that when demo renders, its click stays the same, exactly the same. So it doesn't have to work to create the function again. It only creates it when the demo is created. When the React element by the name demo is created, which means every React element would have its own handle click here, but it won't be recreated for every render. It's created only once when the demo is created. So it's probably indeed something that improves performance. But again, all the things that we saw before, the child here and the function here, these are premature optimizations. In general, they fall into the 97% unless you have a very, very good reason to think that they aren't, that they're part of the critical 3%. It's probably a premature optimization. You probably don't really need to care about these things in your everyday coding. I would say this might look a little better in many cases because you extract this function from the render to the class, and this way you can see exactly how the button is handled. You can see exactly what's the things that this demo can do. So it might be a little readable. So that's probably the only reason why I would write the code like this, but not because it improves performance in any way. Just a waste of time in this case. What about this one? So here we pass an object to the style of this div. It means that on every single reconciliation, it's going to check if the style of this div changed. It's going to see that it indeed changed, and that's a new object, right? It's always a new object on every single render, this one and this one. These are new objects on every single render. Not only that, also the styles would be compared. It's going to compare this one and this one and this one. So we have 7 properties in our case that are going to be compared. So if we do something like this and extract the styles outside of the parent component and pass it like that, instead of recreating the objects on every render, it just does just checks that they're equal, and that's all. And we move to the next thing that the reconciliation has to do. So it also saves performance a little, but I think it again falls into the premature optimization. I only showed these examples to help you think a little about the reconciliation and about how performance can be saved a little in many cases. But if you're pedantic about these things, if you do it all the time, you would find yourself spending a lot of time on it and not performing and not improving your application much. So what really causes performance issues? Google has something that's called rel model, and I really encourage you to read about it. It essentially means that after users, one of the parts of the rel model is that we have around 100 milliseconds to respond to a user's input, like doing something with the mouse, for example, a click, or doing something with the keyboard, like typing. So if it takes you longer than 100 milliseconds to respond, the user would feel a small lag. And that's something to be concerned about. Now, notice that after the input is queued because we have only one thread in JavaScript, as we know, or in the browser. And our input is queued, and it might take up to 50 milliseconds until we actually get to handling it. Then we have something that React does, probably like small handling of it. Then we have our time to actually handle the click. Then, and that's something that I added, the React needs to run its reconciliation, which is very fast, or at least supposed to be very fast. Usually it's very fast. And then the browser does more things like layouting, painting. It has some housekeeping to do. So let's say we have around 50 milliseconds to respond to onClick. In other words, after a non-click, you have to change a state somewhere or update your Redux or Mobix or whatever you use to change states. You have just 50 milliseconds. If you go over it, your user would feel a small lag. And that's an example where it takes more time. As you can see, the user experiences actually a significant lag here, and 3.5 seconds. Because like in this example, whenever a heavy component is rendered, it runs a very, very heavy code. There's like a loop inside the loop here, and the moment difference here, and then another loop, and the thing is heavy. So what it does is it derives some kind of data from existing data. As you probably know, one way to deal with it would be to make the component pure, first of all. So it would help us a lot, actually, because if the user stats and disabled doesn't change, the component won't re-render. It would return exactly the same React element as before. This code here, in case heavy component is pure, would actually generate a new React element, because every call to React create element generates a new immutable React element, but the render function won't be called, and this new React element here would hold the same result as the previous one. Again, as long as user stats and disabled didn't change. So that's essentially how pure components work. And you can pass another argument here. I won't talk about it. You can read about pure components in the documentation again. But it's a great way to ensure that this component only re-renders if one of these changes. But what if disabled is the one that changes frequently? We don't really want to run this code all the time, right? Because if disabled changes, even if our component is pure, this code would run again. So what we do in this case is that we extract the function that derives the data, and we use React use memo. With use memo, this component is not pure, but every time it tries to understand what last month's items are, if these two didn't change, you would receive exactly the same value here, exactly the value that was calculated before, and this function won't even run, this whole function. So if disabled changes frequently, you still would always receive the same result here, unless user is the one that changed, or user stats. If one of these changed, use memo would run, the function inside use memo would run again. We have many ways to memo as data. The reselect library for Redux provides us with create selector. We have use memo that we just saw. Lodash has a memo as function, memo as utility. In Mobix, you can use computed variables to derive data, and there's just many options to do it. But in general, this code is still kind of slow, even with memorizations, because still, if user stats changes, this code would still be kind of slow. It would still take 3.5 seconds to calculate all the things. So that's why you can calculate it in a web worker. I'm not going to show how to do it, but in general, you make this calculation asynchronous, you give it to the web worker, it calculates the result, and just receive it on your side. And it doesn't conflict with the main flow of your application, and the user won't see any lag. You can also show like some kind of loader in that time if you need, if it's a really huge calculation. Another option is to calculate the things in another way, to not calculate it in the client at all. You can calculate it on the server, or you can change your data structure to, for example, you can hold your items in a different table or something and create a special API that retrieves them or retrieves the amount, their lengths, if you want. So again, the moment you understand this, the moment you understand 50 millisecond, 50 milliseconds and less to handle a user action, the solutions come naturally to you. You suddenly understand that, yeah, this thing is kind of heavy and let's find another way to do it, or at least memorize it. Another way to stumble across performance issues is, wait, just want to see that there are no questions. Isn't all of this premature if we haven't measured first? Yeah, probably this all is premature if we haven't measured first. But after you measured, you would probably find out that these things are probably causing your problems. So yeah, start by measuring for sure. Okay, so another way to stumble across performance issues is to have many operations in your React's lifecycle. So the first one is a change high in the hierarchy of the application. So if I have my app here, and it has many components underneath it, and many components underneath it, we have many components in our whole application. If something changes here, okay, in this part, only that would be affected by this change. But if something happens here, then potentially your whole application re-renders. And I said several times that something in the header changes, and suddenly the whole application re-renders. And we will talk on how to improve it. Essentially, just dividing your application into smaller, pure parts. So only the pure part that's affected by the change is actually re-rendered. That's how usually people deal with it. Obviously, you can use like context tests and like different ways to deal with it, but just keep in mind that if something changes high in the hierarchy of your application, it might trigger a lot of renders underneath it. If you have a component like this user has many high order components. Whenever user re-rendered from like something from its parent component or the component that renders it, all these components, high order components, but still components, they have their life cycle running. And if you have, for example, if this like a row in a list, it makes your list much more heavier. It makes your list just tremendous, right? Because not only you have many components, you also each component has many components that have their life cycle run before we even get to user. So that's something that we need to be aware of. If a component re-renders many times, if you have a component and you need to drag it to here, and you do it using React, you start dragging, and each of the smallest states, each move of the mouse is a new render. So in that case, you have many renders, and in this case, you have less than 50 milliseconds to handle them. You have something like 10 milliseconds to handle them, because the user would feel a lag much more clearly if it takes more time to respond. Also, if in many cases we have a lot of instances of the same component or of different components in lists, in graphics, in complex UI, we're going to see an example very soon. And the costly operations that I was talking about, for example, here in this drag example, if you access the DOM to check where are you or check certain things when you drag and drop, sorry, when you are dragging the component, you will probably experience a lag there because this operation is costly. Accessing the DOM it's considered a costly operation. And also creation of React elements. So doing a JSX doing a JSX call and creating a React element is also kind of costly. It's not cheap. So just make sure that, especially if what you're doing involves user interaction, what you're responding to involves user interaction, just remember that if you create a lot of React elements as a result of it, or if you access the DOM, you should be worried about it. You should be wary about it and think how to deal with it. Obviously, first of all, measure. First of all, try to actually dragging the component. See for yourself if it's a lag that you need to deal with, or it works just fine because I don't know, because it works just fine. So before dealing with all these things might be your problems, but start with measuring and trying to understand how your user actually perceive the feature. Okay, in this example, we have this simulation of a graphic component with 10,000 divs inside of it with random colors. And 10,000 is probably, you can find yourself having like 1,000 of React elements with 10 React elements inside of it. If you do something like graphs or something like this, and you want to do it with React, if you want to do it with divs, this operation is very heavy. As you can see, it takes me like 2 seconds, and it feels very, very laggy. Like you click the button and you wait and you wait and you wait, and then it changes. One way to deal with it is to make the component pure. As you can see, I click on the button many times here and nothing changes. But in this case, the thing here won't actually re-render, right? So that's an example where performance issues changes the behavior of your product, and you need to understand exactly how the product wants your feature and to work in collaboration with them to try to understand all the different trade-offs between what you can do with performance and between what they want you to achieve in the product. So if all they want is this red and white thingy here, then you're golden. You're fine. You did what you have to do. This component is memoized and it renders only once. And after that, increase and counter doesn't affect it anymore. And if you look at pure components again, essentially works like this. This component has its state changed. And because it's rendered, this component is recreated. But because it's pure and its props didn't change, all this subtree, which might be huge. For example, if this is our app and this is the dashboard, all the dashboard remains the same. It doesn't re-render at all if it's pure, and what changes only affects this part. Now that's also a pure component, but its props changed, so it renders. And so on. Also, regular components obviously always re-render. Can we make the parent component pure instead of the huge list? So if you have this structure where the parent receives the child and the child holds the huge list, and the huge list is what I showed you before. Can we make this pure instead of the huge list? Because if we do it, we can probably save the rendering of this and that and all of these things and the huge list, right? So that's also something that I saw many, many times. It's also an anti-part in React. The reason for that is that the child component, even if it's pure, it's still a new React element on every use of the JSX syntax. we still use create element. So the parent here receives a new children on every of its renders. It always re-renders because the children is always a new React element. And actually, in this case, not only we save a little, like we improve performance by doing by making this component pure. We also make it worse by making it always compare the children and slowing its life cycle a little. Obviously, it's not like something, not a significant thing, but that's, for example, the reason why not all components are pure, which is a question that people always ask. Why do we need to decide what do we want to make pure? Because of cases like this, where it doesn't make sense to make the component pure and to slow it down to see if any of its props changes, where they always change. Yeah. Yeah, someone asked me about profiling and measuring techniques. Profiling and measuring techniques are super important, but I won't cover them in this lecture. Does React Memo shallow or deep compare? React Memo and all the different pure ways, like you can make the components pure also by extending the pure component class. They only compare shallowly, which means that in our example here, if the user's array itself didn't change, but one of its object inside changed, this component won't re-render. It only compares the different properties shallowly. Okay. Yeah, that's a very important question. And by the way, that's a really good question you asked there, because that's exactly what my library finds out. If you had a re-render where, for example, in this case, father component, the parent component here is pure, right? And you use this feature from the library, why did you render? It would blast your console with warnings. They would look like this. It would tell you that your component re-rendered because your children are different from each other, because the children property is different. Now, obviously, if it changed because of a legitimate reason, like if your property is really changed, the why did you render won't show you any logs in the console. It only tells you that something wrong if something changed, which is not equal but by value. Sorry, which is equal by value, but not by which is yeah, if something changed where it's not equal by reference but does equal by value, it probably means that you have some problem there. For example, if you go to the user's example again, is it? Yeah. If your user's property changed and you have, if you did something like this, your component would re-render, but actually the users themselves didn't change. You don't really want it to re-render. If you make a component pure, you probably expect it to render off only if it's absolutely necessary. And if you always pass, for example, a new user's array here, it's an anti-pattern and one that why did you render can find. Okay. Sometimes React is not the answer. It might be a surprise for many of us. But here I used an off-screen canvas, which is a canvas that can be changed from a web worker, and you can see how many pixels I render, not using React at all. It renders very, very, very fast. By the way, it's 1,000,000 of pixels, so it's much more than in the previous example. And here I also changed the behavior a little because it looks much better like this. If you click a lot on increase counter, the image here changes once in 300 milliseconds. Although you can see that the users doesn't feel any lag. It's very, very fast. So always consider not using React. It's also like in these cases, if you deal with graphics and with very, very complicated UI, or not UI, with graphics mostly, then consider using Canvas, and there's a lot of ways to do it. Okay. See if we have more questions. Someone said that he doesn't think that extracting function like this is premature optimization. It might be a premature optimization because many, many times your code would be much more readable when you go back. This syntax here, in many cases, if it does something small, especially if you have an array above it, it would look much better if you don't extract it. So code readability, I think, is more important here than the performance gain. My opinion, you know. Now this, are you familiar with these huge components? Components that just doesn't end. That if you want to change something, you have to scroll your mouse like for a long time. First of all, it's a really good idea to avoid them because they're just not readable. I mean, yeah, you look at this code and you go like, wow. And also there's a lot of code repetition in this case, which is also something that can happen. It's really hard to spot repetitions if you have a huge component because you can't see the whole picture at once. The solution for this is obviously to break the main component into smaller parts. In our example, because these are fields, right? So you break them into smaller pure parts, as I showed before. And then if this changed, only this one would re-render. Obviously, the main component might be affected by this as well. By the way, with forms, I suggest Formic and Final Form. They're like great libraries. But this example doesn't apply only to forms. This example applies to like many different cases where like big components are very common in React. Try to avoid them as much as you can. This is how it looks after a refactor. It can also probably be improved even more, but when something changes inside of this part, then all these things are not affected by the change, and the application works much faster. Virtualized lists is something that I wanted to mention briefly because there are many great lectures out there on how to implement them, why they're needed, and all the jazz. In general, what we have here is a huge list. Let's say we have thousands of rows, and what the virtualized lists do is that they only show a part of the screen, and they don't render all these parts underneath the screen and above it. Obviously, they have their own implementations, and I actually got to implement one of these once, like to write it from scratch many years ago. But today we have all these great libraries that are maintained by our awesome community of React developers. So I really suggest using libraries in this case. because they dealt with a lot of edge cases. Implementing something like this is not trivial. Okay, so now I come to the conclusions, and you can start asking questions that I'm going to touch just after the conclusion. Yes, so first of all, do not optimize prematurely. I think we talked about it enough in the lecture. It's important to focus always on what's important, both in terms of code readability and both in terms of what do we want to focus our work on. Always consider what needs to be rendered, especially if you have big components or one of the edge cases that I showed before. Try to avoid memos or do heavy calculations in web workers. So heavy calculations, if you see a heavy calculation in your React lifecycle, you should be wary. You should think, do I need it there? How does it affect my user? Not some calculations look heavy, but they're not heavy in reality. So again, try to measure how it works. But in general, heavy calculations should be memoized or moved to web workers, or just find a way to avoid it altogether. Break components into smaller, pure components to make sure that only the right components are re-rendered. And consider tools and methods other than React for specific goals, like graphics for heavy things. Also, by the way, I had this example with dragging a component. You can achieve it with CSS. You don't need React for this. Although, by the way, it works great with React in many, many cases. So it's all about trade-offs. And see if libraries like React Virtualized or other libraries like Reselect and Lodash, they can solve issues that you deal with, because they can make sure that your solution is not you would not encounter bugs that they're already fixed in edge cases. Yeah, that's it. That's all I have. And profiling tools for React by title. Profiling tools. One moment. So first of all, we have the great extension. Like React DevTools is awesome. I mean, it works great. Do I need to? Yeah, I can show it right now, but in general, it's like I'll also write it in the comment so you can see. So it's why did you render that I showed you before. It's like React DevTools and the regular DevTools, Chrome DevTools or Firefox, whatever you use, browsers DevTools. And I think these are the main tools that most of the people are using. Also probably Redux DevTools and different DevTools to monitor the flow of your application can help you. Because if you have too many operations in your Redux, it can also cause performance issues in many cases. Yeah, so that's all for me. Do you want to say some words, Lihi, or someone? Sure, thank you. Bye, thanks.